All right, so today we are doing note solving systems using tables and graphs. You will need your computer because we're gonna play around with Desmos. So if you have your computer, or you can come back to it, but the reason why we're using Desmos is because we do not have access yet for students to have software, the TI Inspire software. So we're using what's free to us to make sure we get the best out of the lesson, okay? So recall, what is slope of a line? The slope of the line is M. What else? What are other ways you remember it? Huh? That's the equation of a line. M. Huh? Anyone else? Y2 minus Y1 over X2 minus X1. What else? What about rise over run? Do you remember that guy? Do you ever remember it? This is the shorthand, delta Y over delta X. That stands for Y2 minus Y1 over X2 minus X1. And it's our rate of change. How are you changing from one point to the other? Okay. Next, we have what is the y-intercept of the line? Well, the y-intercept of the line is what? Perfect. The point where the line crosses the y-axis. Okay, that's your f of 0. It's our f of 0. So if I plug 0 in, what do I get from this? All right, so we're going to talk about the different forms. So here we have slope y-intercept form. That's our y equals mx plus b, right? That's slope y-intercept form. Standard form. Our standard form is ax plus by equals c. And then our point slope form is our y minus y1 equals m times x minus x1. So those are all three ways to represent a line. Do they all look familiar? Perfect, because it should be recall. Okay. And each one tells you different information. So from the first one, m equals your slope, b equals your y-intercept, right? On the second one, to find your slope equals your negative a divided by your b. Your y-intercept would equal your c divided by your b. So from each form, you're able to identify these things. And then point slope is a little different. Point slope is telling you your slope, and you're using a given x1, y1. And you would have to use that information to find your y-intercept. All right. Questions so far? Good? Okay. So our key concepts for this lesson are, we're talking about systems, and systems are when you're dealing with more than one function at a time. So we're talking about linear systems, so we're dealing with more than one line at a time. And this is how your conclusions of what your solutions would be. If I have intersecting lines, we say that they have one solution, it's a consistent system, and an independent system. Okay, so when you have intersecting lines, a couple things are important. So if the lines are intersecting, that means that they have different slopes and different y-intercepts. Okay, coinciding lines. So coinciding lines mean that once I simplify and reduce both lines, they actually are the same. So notice how it was red and blue. Well, what happens when red and blue overlap? They make purple. So that's what coinciding is representing, is that these two lines overlap. They're actually exactly the same. That means that you have infinitely many solutions. It's consistent. It's a consistent system and a dependent system. So what does that mean when you have coinciding? That's one line. They have the same slopes and same y-intercept. And last, we have parallel lines. Parallel lines, if you remember from geometry, they're never, ever, 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 ever going to touch. That means that they have no solution and it's inconsistent. So if we have parallel lines, what do we notice about their slopes? Well, in order to be parallel, you put little parallel marks because they're not very, they're going to have the same slope and different y-intercepts. So based on the slopes and y-intercepts, you can tell me if a system is going to have one solution, infinitely many solutions, or no solution. You can tell me if it has one, infinite, or no solution. That's a horrible infinity. Not sure if I made it any better. Any questions so far? Are you still with me? Any questions? None? We're good? Okay. All right, so solutions. A system can happen in table, graphical, and equation form. We're going to start off with the most basic, which is table form. So if you look here, we have the tables below represent data points of two linear equations, okay? If the linear equations represent a system, what would be the solution to the system? So this is our y1, and this is our y2. When you're looking at a table, you're looking for at what x value are they the same? That's all you're doing. If you're looking at a table, you're looking at what x value are they the same? So our answer would be 3, right? So at x equals 3, right? So therefore our solution is 3, 1. Boom. That's it for tables. Do you think you can handle analyzing a table and finding the solution? Easy breezy, right? Okay. Now we're gonna take it up a notch. We're gonna talk about graphing. Okay, how would you solve it graphically? So if you're solving it graphically, there are 4 simple steps. First, you're gonna solve for y. You're gonna identify and plot the y-intercept, identify and use the slope, and connect the points. And then you're going to look and see where they intersect. You want to do this to the best of your ability because your accuracy determines whether your answer is going to appear or not appear. So for the first one, we either can solve for it or we can talk about how we set in standard form what your slope and your y-intercept are. So if we talk about in standard form, remember how we said if you're in ax plus by equals c form, your slope equals negative a divided by b, and your y-intercept equals c divided by b. Do I have an a? Do I have a b? Do I have a c? So could I easily find my slope and y-intercept without actually solving for y? Yes, but if I'm not comfortable with that, my tried and true way of doing it is just how you did it in your do now, solving for y. So m equals negative 3 over 2. B equals 8 divided by 2. So my b is 4. I'm going to go to 4. And the slope here, a negative times a negative is a positive. So I'm going to go up 3 and over 2. 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. And I'm going to repeat 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. Okay, and I'm going to do my very, very best to connect these. All right, so that's my first line. It's easier to do on paper with a straight edge of some sort. Now I'm going to do the next one. This time A is 1, B is 2, C is negative 8. Again, can I solve for Y? Yes, because that's a skill you already have. I just want to introduce another skill that you can utilize. So M equals negative 1 divided by 2. B equals negative 8 divided by 2, which equals negative 4. So I start at negative 4. I go down 1, right 2. Down 1, right 2. Down 1, right 2. And I'm going to reverse it. And then I'm going to connect. Okay. And bam. Do we see a point of intersection? Why, yes, we do. That point of intersection, that's our solution. This is our solution. And so what is the solution? Bam. Good morning. Come on, sir. Hold on. All right. Do you feel like this is something you could confidently do? Not terrible, right? Okay, cool. Any questions so far? All right, we're going to change gears a little bit. We're going to talk about real world scenarios. I know y'all are so excited about it. Word problems. So biology. The diagrams show the birth lengths of growing rates of 2 species of shark. If the growth rates stay the same, at what age would a spiny dogfish and a Greenland shark be the same length? So the first thing we're going to do is write an equation of a line that would best represent the rates of each shark, okay? So when we talked about what slope meant, remember I told you that it's the rate of change, okay? Your rate of change is slope. So it's telling me the rate here. So this is the slope for this shark. Telling me the rate here. So this is the slope for this shark. Okay. Its birth rate, that's its initial, right? So if it's my initial amount, that's my B. So when I write the equations, we're going to go say Y1 equals, so for the Greenland shark, its rate is 0.775 x, and its initial birth rate is 37. For the spiny dogfish shark, we're going to call that Y2. And its growth rate is 1 and 5/10 x, and its initial is 22 centimeters. I said weight, not length. My bad, y'all. How do you feel about taking information and writing linear equations? Good. So the key things are, what's your rate? What's your initial? What's your starting value? Okay, things like that. Okay, so using the Desmos graphing calculator, we're going to type in Y1, which is our Greenland shark, and Y2, which is our spiny dogfish. Okay, so we're going to change gears here. I'm going to click here. So you just go to desmos.com/calculator, and it'll take you here. Where it says log in, if you just log in with your school, and bam, you're logged in. Okay, so we're going to input what we have. So you're literally going to type Y1 equals, and we said 75 hundredths. What was the initial length? 37? 37. And I can't see, so I'm going to zoom out. And now I can see my graph. I'm going to come over here and type Y2 equals 1 and 5/10 x, 22. Is that right? Is it 22? Okay. Okay, so notice we had to zoom out in order to be able to see what we're doing. So in order to fix it, if I can't see, what do I got to do? Zoom out. Zoom out. That's our key thing. So we clicked on the equation. Now we're going to click on the equation. I'm going to show you how to access the table. So to access the table, you click here and you see this little gear that allows you to access the table. And now you can see table values. Same thing here. Click on it. Click on the gear. Accesses the table. So if we were to look at the tables and compare, remember how we said if you're comparing tables, you're looking for when they are equal. To make your table grow, you just press the X box and you're going to press enter, and your table will grow on its own just by pressing enter. So as of right now, the Greenland fish is already larger than my spiny fish. So I need to know, when is the spiny fish going to catch up to the Greenland fish? And so now if I'm looking at it table-wise, I have some catching up to do. And as you're building the table, you can see that it's building the point. So at what length are they the same? Let's see, where am I at? So this one, because it doesn't do side by side, it makes it a little hard. But that, I just wanted you to see how to make a table and how to build the table in Desmos. Literally click in the X box and hit enter, and it continues to build. And I like how as you build, it keeps putting the points. Do you see how it's adding the points to your graph? So if I kept building here, now I can see graphically and on table, at what point are they the same? 2052. I can then come over and hover here, and it also verifies that it's at 2052. Now, to me, I'm a by the hand person. I would have just set them equal to each other and solved for X and solved for Y. But I'm going to show you that there's technology. But don't forget by hand. It's your friend too. Okay? So when we found, what does the point represent? So we found our answer to be 20, 52. What does that mean in terms of this problem? What does 20 represent? Exactly. So this means in 20 years, both sharks will be 52 centimeters long. So the good thing about having the table and the computer and technology is that when you have additional questions, you can easily answer those questions, right? So it says here, after 25 years, what would be the length of the two sharks? So after 25 years, what would be the length of two sharks? Well, let me go look. Let me go back to my, so the length of the two sharks after 25 years, I can just either click enter on my table, and the Greenland shark would be 55 and 7,500 centimeters. Click enter here. And the spiny would be 59 and a half centimeters long. And there we go. I know my value. The other good thing is you can actually just type it in. So like if I wanted 25, I can type in 25. I didn't have to click enter. I just wanted to show you that you can continue. But if the number was really large, like it said after 50 years, how long would they be? I don't want to hit it 50 times. I can type in 50 and find out 97 centimeters. Does that make sense? Okay. But we're asking for 25. So after 25, it would be 59 and a half for one and 55 and 3/4 for the other. I'm going to call them G and S sharks. So the G shark. Oh, no, what are you doing? Oh, okay. It said I was done taking notes, y'all. I was not. All right. The G shark was 55 and 3/4, I think. And the S shark was 55 and a half, 53 and a half, 55, 59. Thank you. And it's like at this point, at what point is the spiny dogfish longer than the Greenland shark? Well, it's after 20 years, right? That intersection is where the transition happens. So after 20 years. Because at that point, that's when that shark is now continually larger than the other shark. Okay, how do you feel about navigating with Desmos for now until we get our TI Inspire software? It's not terrible, right? Okay, cool. Well, that concludes our notes. At this point, we go, be a student. You should be able to go to week 8. And you'll see your practice. And to open the practice in the window, you press the magnifying glass. To open it within Canvas, you press the magnifying glass, and it'll load in Canvas. To open it in another window, you just press the link and it'll open it, and you have to download it. So whichever one you want to do. My computer's running slow for some reason, but it'll load within Canvas that way, or opening it and downloading it. Okay. All right. So questions, comments, concerns about what we've done today? None? Cool, cool, cool. So I'm going to go ahead and open it so you can see it. You have graphs where you're practicing graphing and finding the solution. Here, you're not graphing, you're just classifying. So whether it's independent, dependent, or consistent. So are they intersecting? Are they parallel? Or are they coinciding? And then your last problem is you're writing a system and finding your answer. And that's it.